Hi, so today we're going through the PAT paper from 2016 looking at question 11. So in question 11 we're told a cylinder is squashed such that its height decreases and at time t, h of t is h0 minus alpha t for constants h0 and alpha. We're told to assume that its volume v is constant and that it remains a cylinder. And we're asked to find an expression for the rate of change of the radius and asked is it increasing or decreasing. Okay, so what we're going to do is we'll start by sketching this in. So we have our cylinder here. So just a general cylindrical object with a height that I've been told is h of t and a volume v. Okay, so we know that the time at time t is h0 minus alpha t. And we're told v is a constant throughout. Well, what does it mean if v is a constant? Well, that means that its time derivative is 0, because the derivative of a constant is 0. So this implies that dv by dt is equal to 0. But what is the volume? Well, we know that the volume of a cylinder is equal to pi r squared h, where r is its radius and h is its height. Well, therefore, we know v is equal to pi r squared times h, which is h0 minus alpha t. Well, we can then find the time derivative. So therefore, we know dv by dt is equal to, right, well, let's expand this out. So that's d by dt of pi r squared h0 minus pi r squared alpha t. Okay, so let's perform that. Well, that's equal to the time derivative of the first term. So what's that? So that's a constant, pi is a constant, h0 is a constant, so it's a time derivative of r squared. So it gives us a 2 pi r h0, and we have to add a dr by dt on the end. So that gives us 2 pi r h0 dr by dt. And well, in the second term, we have to do the product rule. So first of all, we have the time derivative of r, so it gives us 2 pi r alpha t dr by dt. So that's minus 2 pi r alpha t dr by dt. And then it's derivative of the second term, t. So it gives us minus pi r squared alpha, because dt by dt is 1. So it gives us minus pi r squared alpha. Well, that factors out to 2 pi r dr by dt into h0 minus alpha t minus pi r squared alpha. And we know that this is equal to 0 because dv by dt is equal to 0. Well, then this tells us that 2 pi r dr by dt times h0 minus alpha t is equal to pi r squared alpha. Or cancelling off pi's and powers of r, we get dr by dt is equal to r alpha over 2 into h0 minus alpha t. Now, is this increasing or decreasing? So is dr by dt positive or negative? Well, we know that we've been told in the question t is strictly less than h0 over alpha. Well, that means that alpha t is strictly less than h0, and therefore h0 minus alpha t is always going to be positive, so always dividing by a positive value. And while the radius is positive, and well, we're going to have to assume for the sake of argument that alpha is a positive value. So if alpha is positive, then we get that the rate of change of the radius is increasing. So, sorry, the radius is increasing. So if alpha greater than 0, it's increasing. But if alpha is less than 0, it's decreasing. And this makes sense intuitively, because if alpha is greater than 0, then the height is going to be decreasing, and so to keep the same volume, it must be getting wider. If alpha is less than 0, the height is increasing, and so the radius must be getting smaller for the volume to remain constant. But we've been told in the question that it's squashed, and so we're going to have to assume that alpha is strictly greater than 0, and so the radius is increasing.